The digital boom might hit a wall within 25 years because there will not be enough electricity to power all the world's computers, experts have said. A report has warned, if current trends continue, we will be running short of electricity to power these machines by as soon as 2040. This means radical improvement of the energy efficiency of computers is drastically needed to enable us to keep increasing the amount of computing power used around the world. The report, by the Washington, D.C.-based Semiconductor Industry Association and the Semiconductor Research Corporation, includes a chart which shows for the amount energy needed per bit, computing will not be sustainable by 2040. This is when the energy required for computing is estimated to exceed the estimated world's energy production. But experts do not believe this nightmare scenario will become a reality. The chart is obviously a back-of-the-envelope extrapolation that is meant to make a point, Celia Merzbacher, VP of Innovative Partnerships at Semiconductor Research Council told Semiconductor Engineering. It's not realistic to expect that the world's energy production is going to be devoted 100% to computing, so the question is, how do we do more with less and where are the opportunities for squeezing more out of the system? For this benchmark energy per bit, computing will not be sustainable by 2040, when the energy required for computing will exceed the estimated world's energy production, the report said. Thus, radical improvement in the energy efficiency of computing is needed. The chart uses a physics-based device-level theoretical lower limit, known as the Landauer limit for binary switching, and a practical limit for energy consumption. The energy limit is named after IBM Research Labs' Rolf Landauer, who in 1961 found that in any computer, each single bit operation must use an absolute minimum amount of energy. Landauer's formula calculated this lowest limit of energy required for a computer operation. Researchers are already working on finding ways to limit computing power. For example, in March this year researchers demonstrated it could be possible to make a chip that operates with the lowest energy possible under the laws of physics. It's been called a breakthrough for energy-efficient computing and could cut the amount of energy used in computers by a factor of 1 million. But it will take a long time before we see the technology used in our laptops. Others have argued the predictions of the chart are flawed. But the trend is unlikely to continue at the same rate it has been in recent years, experts not involved in the research noted. Anytime someone looks at a growth rate in a relatively young segment and extrapolates it decades into the future, you run into a problem that nothing can continue to grow at exponential rates forever, said Chris Rowan, Cadence Fellow and CTO of the company's IP group to Semiconductor Engineering. By definition you're going to run into some limits sooner or later. There may be hand-wringing over it, but very rarely does it mean the end of the world if you can't extrapolate in the conventional fashion. He said the system follows any normal economic trend, that when something is plentiful it is cheap, and as it becomes more scarce it becomes more expensive and people find alternatives. In the long term, people are considering radically different ways of computing, including quantum computing. Quantum computing takes advantage of the ability of subatomic particles to exist in more than one state at any time. This means operations can be done much more quickly and using less energy than classical computers. Another alternative way of computing is neuromorphic computing, which tries to mimic the nervous system. Earlier this year, Lawrence Livermore National Laboratory and IBM revealed a new deep learning supercomputer they say could boost high systems. Based on a neurosynaptic computer chip called IBM True North, it can replicate the equivalent of 16 million neurons and 4 billion synapses, yet consumes just 2.5 watts, the energy equivalent of a hearing aid battery. Given the immense challenges of lowering the energy requirements of computing in the future, it is obvious the task will be accomplished with all hands on deck, said Anne-Story Muchler, executive editor at Semiconductor Engineering. And given the impressive accomplishments of the semiconductor industry in the past 50 years, there's no doubt even more technological advancements will emerge to hold back the threat of hitting the energy wall.